Hi everyone. In last video, I explained DLC services one. Nothing but in last video I explained framing, that is data link control service one framing is completed. In this video I am going to explain DLC service includes second one service called flow and error control. Okay, in this video I am going to explain flow and error control. Actually, in detail, error control is explained in last module, third chapter. Means error correction and detection ಅಲ್ಲಿ ಫುಲ್ಲಿಯಾಗಿ ಎರರ್ ಕಂಟ್ರೋಲ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದಾಗಿದೆ. In summary, I will going to explain flow and error control in this video. Okay, flow control and error control. One of the responsibilities of DLC sublayer is flow and error control at the data link layer. Means at data link layer we are going to give the responsibility is that to control flow and error. Okay, now what is meant by flow control? Whenever a entity produced item and other entity consume them, there should be a balance between production and consumption rate. Means suppose consider there will be two nodes A and B. A will send the item, B will receive the item. Okay, the sending rate and consuming rate should be balanced. That is only they are telling. What is meant by flow control? Means the production means sending rate and receiving rate should be matched. Suppose if the items are produced faster than they can be consumed, the consumer can be overshadowed and may need to be discard some item. Means the sender will send the items at very fast rate, then the B consuming them. Means it will be faster, but we will be slower in consuming the that item. In that time what will happen? B may be overloaded or some of the item will be lost. Means suppose A will send the items at very fast rate, then the B can consume them. Means it will send faster than the B can consume. At that time what will happen at the receiver side B? Means it may be overloaded or it may be lost the items. Okay, to overcome this problem we need to prevent losing the data item at the consumer side. Means we have to overcome this problem. What is the problems? I told that it may be overloaded or we can lose the item. Okay, here you can see that sending node, receiver node. This is frames are pushed. Means the sending node pushing the frames to receiver. Okay, here if the rate of receiver is less than the pushing rate, the receiver node can be overloaded or it may lose some of the frames. Okay, to overcome this, flow control can be feedback. So overcome this means we have to balance from both sides. Means we have to use flow control. This is the feedback from the receiver node to sending node to stop or slow down the pushing frame. Means they are telling that you have to using the flow control to overcome this problem of overloading and loss of frame in the receiver side. The receiver should be tell to sending that please slow down or stop the pushing frame. To overcome this problem, we are going to use flow control as a feedback from receiver to sending that please stop the frame or to slow down the pushing frame, so that we can not overload and we cannot lose the packets also. Okay. Buffers. What is meant by buffers? I told that to overcome this problem we are using the flow control. How this flow control will be achieved? The flow control will be implemented by using buffer. Using buffer, we can implement a flow control. Buffer is a set of memory location that can be hold packets at the sender and receiver. Buffer is nothing but set of memory location present in the sender side and receiver side which can hold the packets. Normally two buffers can be used. Means two buffers are used. One at sending side, another at receiver side. Buffer at the sender side and the receiver side. Flow control, communication done by sending signal from consumer to produce. Buffer of the receiver is full. It informs to sender to stop the pushing frame. Means what this buffer will do means the receiver will give the information to sending that there is no place for the pushing frame. Please stop the pushing frame. That is the end of this flow control. What is flow control? The sending rate and consuming rate should be balanced. How? If not the sending rate and consuming rate are not balanced, means there will be a overloaded of frames or loss of frames in the receiver side. To overcome that, we are going to use flow control. What flow control will do means when there is a overload or there is a loss of packet, the receiver will inform to sender that please stop or slow down the pushing frame. How this flow control can be implemented? The flow control can be implemented by buffer. This flow control can be implemented by buffers. What is mean by buffer? Set of memory location that holds packet at the sending and receiver. Means there is a set of location in the sending side also on the receiver side. It will hold the packet. We are using two buffers, only that the receiver, another on the sending. Means what this buffer will do, if there is no space in the receiver, it will inform the sender, please stop the pushing of the frames. Next, error control. Flow control is over. Next one is error control. Error control is nothing but error detection and error correction. I briefly explained in the last module, last chapter. In third module, third chapter, we have fully discussed on error detection and correction. Okay, error control allow receiver inform to sender of any frame lost or damaged in the transmission. Means error control ಏನಾಗುತ್ತೆ, the sender will give the information to receiver that any frame lost or damaged in the transaction time ಅಲ್ಲಿ ಯಾವ್ದಾರ ಪ್ಯಾಕೆಟ್ಸು ಲಾಸ್ ಆಗಿದ್ರೆ ಇಲ್ಲಾಂದರೆ ಡ್ಯಾಮೇಜ್ ಆಗಿದ್ರೆ ಇಟ್ ವಿಲ್ ಗಿವ್ ದಿ ಇನ್ಫಾರ್ಮೇಷನ್ ಫ್ರಮ್ ರಿಸೀವರ್ ಟು ಸೆಂಡರ್. ಓಕೆ, ಟು ಇಂಪ್ಲಿಮೆಂಟೆಡ್ ದಿಸ್ ಫ್ಲೋ ಕಂಟ್ರೋಲ್ cyclic redundancy check is applied. Means added to frame header by sender and checked by the receiver. What is cycle redundancy check in the error controls? We fully discussed on this CRC. Okay, nothing but addition to the frame header by the sender. Means this will be added to the header at the sender, that will be checked by the receiver. Means adding is there, present or not is checked by the receiver. This is added by the sender. Next, at the data link layer, error control implemented using one of the two methods. There are two methods are there. Using any one of this method, we are going to implemented this error control in the data link layer. What is the first method? If frame is corrupted, it is discarded. Frame is not corrupted, the packet is delivered to the network layer. Means first method is frame is corrupted. Means frame ಏನಾದರೂ ಕರಪ್ಟ್ ಆಗಿದ್ರೆ you are not going to accept, it will be discarded. Frame is not corrupted means the packet is delivered to next upper layer, nothing but network layer ಗೆ ಟ್ರಾನ್ಸ್ಪೋರ್ಟ್ ಮಾಡುತ್ತೆ. ಇದೇನೋ ಕರಪ್ಟ್ ಆಗಿದ್ರೆ we are not going to accept or send to any other layers. If it is not corrupted, the frame is not corrupted, we are going to deliver the packet to the upper layer, nothing but network layer. Next method is if frame is corrupted, it is discarded. Means if frame is here also we are going to discard, here also we are going to discard. Okay, if frame is not corrupted, an acknowledgement is sent to sender. Means the another method is sending the feedback from the receiver to sender that the send frame is successfully accepted. By sending the acknowledgement na ನಾವು ಕಳಿಸಿದೀವಿ ಅಂದರೆ it will indicate that receiver is successfully received what we sent, the frame is not corrupted. This acknowledgement is used for the process of both flow and error control. Means this acknowledgement na ನಾವು ಫ್ಲೋ ಕಂಟ್ರೋಲ್ಗೂ ಯೂಸ್ ಮಾಡ್ಬೋದು, ಎರರ್ ಕಂಟ್ರೋಲ್ಗೂ ಯೂಸ್ ಮಾಡ್ಬೋದು. ಓಕೆ, ಐ ಟೋಲ್ಡ್ ದಟ್ ದಿ ಎರರ್ control implemented using one of the two methods in the data link layer. First one is here we are not going to use acknowledgement, here we are going to use acknowledgement. Frames is corrupted, it is discarded. Here also frames is corrupted, it is discarded. In this method, frames is not corrupted, the packet is delivered to the network layer. Means ಏನಾರ ಫ್ರೇಮ್ಸು ಕರಪ್ಟ್ ಆಗಿಲ್ಲ ಅಂದರೆ ಇಟ್ ವಿಲ್ ಡೈರೆಕ್ಟ್ಲಿ ಸೆಂಡ್ ಟು ದಿ ನೆಕ್ಸ್ಟ್ ಲೇಯರ್, ನಥಿಂಗ್ ಬಟ್ ನೆಟ್ವರ್ಕ್ ಲೇಯರ್. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಈ ಫ್ರೇಮ್ ಇಸ್ ನಾಟ್ ಕರಪ್ಟೆಡ್, ದೇ ವಿಲ್ ಗಿವ್ ದಿ ಫೀಡ್ಬ್ಯಾಕ್ ಟು ದಿ ಸೆಂಡರ್ ದಟ್ ಯುವರ್ ಫ್ರೇಮ್ಸ್ ಈಸ್ correct and it is accepted ಅಂತ it will give the feedback. And this acknowledgement is used for process of both flow and error control. Means this acknowledgement na flow control ಆಗು ಯೂಸ್ ಮಾಡು, ಎರರ್ ಕಂಟ್ರೋಲ್ ಆಗು ಯೂಸ್ ಮಾಡು. ನೆಕ್ಸ್ಟ್ ಕಾಂಬಿನೇಷನ್ ಆಫ್ ಫ್ಲೋ ಆ್ಯಂಡ್ ಎರರ್ ಕಂಟ್ರೋಲ್. ಇಯರ್ in In one way only you can combine the flow and error control mechanism. Here flow control and error control can be combined. ASCII send for the flow control can also be used for the error control. Means acknowledged send for flow control can also be used for error control to tell the sender the packets are arrived uncorrupted, and lack of acknowledgement means suppose there is lack of acknowledgement means there is a problem in the send frame. Means A to B ಇರುತ್ತೆ, ಫ್ರೇಮ್ ಕಳಿಸಿರ್ತೀನಿ, that is not corrupted, it will send the acknowledgement. Okay na? Acknowledgement means the frames is not corrupted, it is accepted successfully. It will be send the A feedback by giving the acknowledgement. Okay. If suppose this is not happen means this is lack of acknowledgement means there is a problem in the send frame. Means here there may be a problem in send frame. The frame that carries the acknowledgement is called means this is called as acknowledgement. This is distinguished that the data frame means ಫ್ರೇಮ್ಸ್ಗೆ ಫ್ರೇಮ್ಸ್ ಅಂತಲೇ ಕಳಿಸ್ತೀವಿ, ಇದನ್ನು ಫ್ರೇಮ್ ಅಂತ ಕಳಿಸ್ತೀವಿ. ಬಟ್ ಅಕ್ನಾಲಜ್ಮೆಂಟ್ ಈಸ್ ಕಂಬೈನ್ಡ್ ವಿತ್ ದಿಸ್ ಫ್ರೇಮ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಕರೆಕ್ಟ್ ಆಸ್ ACK to differentiate between frame and acknowledgement frame. Next one is connectionless and connection oriented. Connectionless protocol is nothing but suppose if you are sending the frames from one node to another node, the receiver can receive the frame from many of the other nodes. There is no numbering for that frame. It will be maintained by the protocol. Means the B is the receiver means B is the receiver node means it can receive the frames from A, C, D like this. B is the receiver, it can be received from any of these nodes. Okay, there is no numbering from the frames ke number iralla. Next frame is from which side we don't know, which sender we don't know. So this maintaining of flow of frames is maintained by the connectionless protocol. Here connection oriented protocol, before communication there should be a connection between A and B node. Here frame 1 related to message D means frame 2 also related to message D means there is a number for each of the frames. Each frames is related to the next packet is or frame is related to this previous packet or frames. Okay, there will be a numbering because there is a connection before communication, that is connection oriented protocol. Here there is no connection, this transmission should be happen through the protocol only. Here connection protocol is very important to flow of the frames or packet from one node to another node. Here there is a connection established between A and B, and we are going to transmit the data. Okay, data containing many frames. These frames are related to each other because the frames is of data type. Okay, thank you. Tomorrow I am going to explain in next video data link layer protocol. There are two types, simple protocol and simple protocol and stop and wait protocol. In next video I am going to explain this. After this, triple P concept is there. That is the end of this chapter. Okay, thank you.